Hello friends, we are continuing the second half of the unit 5, that is modern surveying. It consists of various types of latest equipments. In this video we try to see about the basic concept for those modern equipments, right? We starts with electronic distance measurement, EDM. In short, it is EDM. We know distance measurement can be done either direct or indirect. Direct method is using chain or tape. In indirect distance measurement, the two concepts we can use is, one is geometrical, that is optical. We have already discussed about the theodolite or tachometric surveying. Next comes to the electronic portion. The concept behind is wave physics. So in this, the principle of operation is velocity is equal to distance by time. This is the basic physics. We have already studied in our school education itself. That is the principle we try to use here, right? It starts from World War II with the development of radar, that is radio detecting and ranging. Radars return the distance to an object, that is the concept of Doppler shift, by timing the length of time from the transmission of pulse to its return. Accuracy was set by timing resolution. So 1 microsecond is equal to 300 meters. In 1949, Dr. Erik Beckstrand of Sweden introduced the geodemeter, that is geodetic distance measurement, that used light, 550 nanometer wavelength, to measure geodetic quality distances. Instrument weighed 100 kg. Can you imagine 100 kg? Later, first introduced in the late 1950s. At first they were complicated, large, heavy, and suited primarily for long distance. Current EDMs use either infrared light waves or microwaves, that is radio waves. Microwaves require transmitters and receivers at both the ends. Infrared use a transmitter at one end and a reflecting prism at the other, and are generally used more frequently. Today, the infrared based equipments are available more. Distance range was about 10 km during daylight and 25 km at night. Why at night is high? Compared to the daylight, sunlight becomes predominant. In night, the infrared travel can be detected very fastly, right? So this is the advantage of this EDM equipments. Greater range during daytime was achieved by using radio waves, and in Dr. T.L. Wadley, South Africa, introduced the telerometer in 1957. Instrument used X-band radio waves, that is 10 GHz. Receive and transmit ends look similar. Receiver actually retransmitted the signal. The geodemeter used one or more corner cube reflectors, what you will see. Distances up to 50 km could be measured in daylight with this instrument and later models. EDM properties, you have to remember these things. They come along 10 to 20 km, medium 3 to 10 km, and short range is 0.5 to 3 km. Range limits up to 50 kilometers maximum. The EDM can be used. They are typically mounted on top of a theodolite, but can be mounted directly to a tripod. Whatever the setup we are discussed about the theodolite, it is applicable to these EDM also. So in that latest one is total station. It is the combination of theodolite with built up in EDM plus or minus microprocessor. If the microprocessor is not available, it is electronic theodolite. If it is combined with microprocessor, it is called total station. You have to remember this thing. Theodolite with EDM principles alone is called electronic theodolite, and if it is added with microprocessor, where the data can be stored, recorded, and it can be retrieved for the further process, then it is called total station. right? So the microprocessor plays a major role. Classification of EDM described by form of electromagnetic energy. So the electromagnetic waves, it is the most predominant one which rules the measurement. It is the basic concept for the later portion of our unit is remote sensing and GIS. First instruments were primarily microwave in 1947. Present instruments are some form of light, that is laser or near infrared lights are used. Described by range of operation, generally microwave or 30 to 50 kilometer range. Developed in early 70s and were used for controlled survey. Light EDMs generally 3 to 5 kilometer range, short range, used in engineering and construction purpose. The bottom is the thing we predominantly used in civil construction field. It starts with the geodemeter. First unit circa 1959, it was developed 50 kg. This equipment is each for measured unit. Later model geodemeter, it developed in 1966. It is the less reduced weight. Both the front view and the back view you are seeing with the telescope like model where the signals are sent and received and further process were made. Next comes to the tellurometer. Sorry, here spelling mistake. Tellurometer, example of circa 1962 model, and the bottom one is 1970s version. It is 1.7 kg from 50 kg, 100 kg to 50 kg. From that 9 kg, then 1.7 kg. The minimization of the equipment has made. Modern version. These types of measurements are now directly built into the telescope assemblies of theodolite, and you can see these are on most construction sites. The angles are now also read electronically compared to glass optical circles. Modern in 2000 it was made. This is the corner cube reflector infrared light source used. In this there are prism is built up, where when the signal is transmitted and hit this prism, it reflects back. Based on that we will measure the distance or whatever the thing, right? And this is the modern version, and from here many editions made. Now we are using the total station in different formats. Today latest is robotic total station. It works automatically without human intervention. EDM is very useful in measuring distance that are difficult to access or long distance. It measures the time required for a wave to send to a target and reflect back. That is, from the transmitter instrument, the signal light beam is sent, the reflector, the prism, it hits and back. This is the principle used in measuring the long distance. So, principle of EDM, again here it is detailedly explained. A wave is transmitted and returning wave is measured to find the distance traveled. Say EDM instrument, it sends the signal and it gets back from the prism. See, the ups and downs of wave is called sinusoidal wave. Both the trough or both the ups is considered as a wavelength distance, right? Which was you already studied in the physics. So the modulated electromagnetic energy, it transmitted and get reflected. So the return energy also, based on this, when it hit back the prism and it come back, this concept is used to measure the distance. So the transmitted energy and the return energy, right? So the electromagnetic energy travels based on the following relation: velocity is equal to frequency into wavelength. So therefore wavelength is equal to velocity by frequency, and again velocity is is equal to C by N, the number of cycles, right? That gives the intensity modulated electromagnetic energy to specific frequency, which how we can relate to the distance. We will see distance is equal to velocity by time. So this velocity can be used, and the time taken, it is also recorded in the microprocessor. Based on that velocity and the time, we can get the distance. So the distance determined by calculating the number of wavelengths travel, number of wave 1, 2. So it is 2 times, we required one distance only, by 2 we have to do. So the length is equal to n lambda plus phi by 2. Errors are generally small and insignificant for short distances. For longer distance, they can be more important. Errors can be accounted for manually or by the EDM if it has the capability. Velocity of light can be affected by based on the following factors: temperature, atmospheric pressure, water vapor content. If it is the temperature is high or the atmosphere is high, water vapor content is high or low, whatever it is, it affects the wave travels, right? Based on the infrared, it is different, microwave it is different, normal visible light it is different. So based on the type of light, it affects. The characteristics of EDM, it ranges from 750 to 1000 meter range, accurate to plus or minus 5 mm, plus 5 ppm, parts per million. Operating temperature between minus 20 to plus 50 degrees centigrade. 1.5 seconds typical for computing a distance, 1 second when tracking. Slope reduction, either manual or automatic, can be available. Some average repeated measurements, signal attenuation, battery operated, and can perform up to 350 and 1400 measurements. Nowadays it improves for more than 20,000 points. This is the prism. 3 prism model, single prism model. Predominantly nowadays in short range or medium range, we use the single prism model. For long range, triple prism model we are using, made from cube corners, have the property of reflecting rays back precisely in the same direction. They can be tri-back mounted and centered with an optical plummet, and they can be attached to a range pole and held vertical on a point with the aid of a bullseye level. Either by tripod stand for standard accurate center we can hold, or portable poles are available to hold the prism, and we can carry wherever we have to hold. Right. Prisms are used with electro-optical EDM instruments to reflect the transmitted signal. A single reflector is a cube corner prism that has the characteristics of reflecting light rays precisely back to the emitting EDM instrument. The quality of the prism is determined by the flatness of the surface and the perpendicularity of the 90-degree surface. Accuracy. Distance is computed by number of wavelengths generated plus partial wavelength by 2. Standard or random errors are described in the form of plus or minus constant plus parts per million. Constant is the accuracy of converting partial wavelength to a distance. ppm is a function of the accuracy of the length of each wavelength and the number of wavelength. So EDM accuracy in detail. Typical accuracy is plus or minus 5 mm plus 5 ppm, already we have seen. The blunders may happen in incorrect meter settings, incorrect scale settings, prism constant, ignored incorrect recording settings. These are the blunders may happen, which results in the error. Both the prism and EDM should be corrected for off-center characteristics. The prism or instrument constant about 30 to 40 mm can be measured by measure AC, AB and BC, and then the constant can be determined. Source of error in EDM: personal error, instrumental error, natural error, obviously for all the equipment. Personal careless centering of an instrument, biggest error. In latest utilization, without proper centering, the instrument won't start work itself. So which governs the personal error can be avoided. Faulty temperature and pressure measurements, incorrect input of temperature and pressure, wrong information may lead to the error. Instrumental error, instrument not get calibrated properly, electrical center or electronic center was not properly. Prism constant, we will discuss in the next slide. Natural error, varying met along line, turbulence in air, in pressure, temperature are the natural errors. Determination of the system measurement constant, measure AB, BC, AC. AC plus K, the K is the constant to be determined, which is equal to AB plus K plus BC plus K. What is the K? The K can be calibrated as AC minus AB plus BC. Right? If the electrical center is calibrated, K represents the prism constant. Never mix prism types and brands on same project. Different prisms don't change in the single survey. Right? If you use a particular prism, you try to carry out for the entire project and calibrate properly regularly. That is the good practice. Systematic errors are instrumentation errors. Microwave, the atmospheric conditions plays a major role. That is temperature, pressure, humidity. Must have wet bulb and dry bulb temperature. Multi-path waves, reflected signals can give longer distances. Light, the light wave atmospheric condition alone affects the temperature and pressure, not the humidity, but the microwave is affected by humidity also. Prism offset, point of measurement is generally behind the plumb line. Today usually standardized as 30 mm. EDM instrument operation setup. EDM instruments are inserted into the tri-bar, set over the point by means of optical plummet. Prisms are set over the remote station point. The EDM turn on. The height of the prism and the EDM should be measured. The EDM is aimed at the prism by using either by built-in sighting device on the EDM. Telescope will have the optical line of sight a bit lower than the electronic signal. When the crosshair is sight on the target, the electronic signal will be maximized at the center of the prism. Set the electronic signal precisely on the prism center. Then we can measure. The slope measurement is accomplished by simply pressing the measure button. The displays are either a liquid LCD or LED. Nowadays LED is available. Touch screens also available. The measurement is shown in 2 decimals of a foot or 3 decimals of a meter. EDM with the built-in calculator can now be used to compute horizontal and vertical distance, coordinate, atmospheric curvature and prism constant. Even the input operation they give area, volumes, everything. It can be recorded. The measured data can be recorded in the field node format, can be entered manually into electronic data calculator. In latest inbuilt storage is available, and through USB attached it can be transferred to the system also. Nowadays Bluetooth and net facility, if you can connect, we can transfer like just like in the mobile we are using. The same operation can be done in latest equipments. The distance must be accompanied by all relevant atmospheric and instrument correction factors. So users, we can measure the topographic measurement, and as built we can use construction layout, we can do monitoring, control can be done properly. Total stations are ideal for collecting large number of points. They are commonly used for all aspects of modern surveying. Only when harsh conditions exist or distance short will transit and tapes are used. Disadvantage: total stations depend on batteries and electronics. The LCD screen does not work well when it is cold. Battery life is also short. Batteries and electronic both do not work well when wet. Total stations are typically heavier that transit and tape. Loss of data is an important consideration. Properly it has to be handled. Thank you, friends.